Performance evaluation of grid-connected solar photovoltaic plant using PVsyst software. Abstract: due to increase in the price of fossil fuel and decrease in the coal resources, renewable energy has become the new future of energy generation of India. The time of coal-based power generation has come to its end, thus it's imperative to look for new and innovative ways to generate energy. Renewable energy is slowly but surely making its way into every household. The focus of our project is out of all the available renewable energy sources, solar energy is the most abundant, and is basically an infinite source of energy. This energy has to be put to proper use in order for humanity to reach new levels in innovation and technology. There is a huge scope solar energy in India in states like Karnataka, Telengana, Rajasthan, Andhra Pradesh, Tamil Nadu, Gujarat etc. There are about 23,789 sq km area of land in non-productive use. Rajasthan is a desert and it receives ample amount of solar energy throughout the year and very little rainfall. Therefore it is an ideal place for the construction of a solar power plant. PVsyst is a software used to design solar panels or even a solar power plant. Keywords: PVsyst, photovoltaic system, solar plant, renewable energy. Introduction. Due to increase in the price of fossil fuel and decrease in the coal resources, renewable energy has become the new future of energy generation of India. The time of coal-based power generation has come to its end, thus it's imperative to look for new and innovative ways to generate energy. Renewable energy is slowly but surely making its way into every household. The focus of our project is out of all the available renewable energy sources, solar energy is the most abundant, and is basically an infinite source of energy. This energy has to be put to proper use in order for humanity to reach new levels in innovation and technology. There is a huge scope solar energy in India in states like Karnataka, Telengana, Rajasthan, Andhra Pradesh, Tamil Nadu, Gujarat etc. There are about 23,789 sq km area of land in non-productive use. Rajasthan is a desert and it receives ample amount of solar energy throughout the year and very little rainfall. Therefore it is an ideal place for the construction of a solar power plant. PVsyst is a software used to design solar panels or even a solar power plant. 2. Methodology. There are various components in PVsyst software. The specifications for these components are researched and entered in the software. The software collects all the data and simulation is run on the software and result is produced. The various components whose specifications are researched and entered are the geographical site and its weather conditions throughout the year, the orientation of solar panel, the various components of the system, the details of losses, the horizon, and the stimulation is generated. Meteo database. So since we have selected the site we have to enter the geographical data of the particular location. There is feature called interactive map where we can select the geographic allocation of the site. The latitude of the site is 28.2900 north and longitude 74.2343 east. Altitude 249 above sea level. Other data like horizontal global irradiation, horizontal diffusive irradiation, temperature, wind velocity, link turbidity, relative humidity on a per-month basis throughout the year could be found from the Meteo norm. The figure 1 below will give you the data. B. Orientation. The orientation of the solar panel decides the tilt angle and the azimuth angle. There are various field types available. For this project, seasonal field type is used. Due to the sun path and geographical we kept a summer tilt of 16 degree and winter tilt of 47 degree and because there is no elevation the azimuth is 0 degree. This is kept to ensure minimum amount of loss during the summer and winter months. In Rajasthan winter falls from October to March so tilt will be kept 47 degree and from April to September it is kept 16 degrees. See configuration of the system. The simplified schematic diagram of the system is given below. The PV array is connected to an PV inverter which is then connected to a battery where the energy is stored. As shown in figure 3. 1. PV array. Solar cell. A solar cell is a PN junction diode made of silicon. A current is produced when electrons are moved in the diode due to hitting of the sun's rays. As shown in figure 4. A number of solar connected in series forms a solar module. Then a number of solar modules connected in series are called a solar string. Then a number of solar strings connected in series is called a solar array. As shown in figure 5. 2. PV module that is being used in this project is 250 WP26VSI mono 250 WP60 cells bifacial since 2015. The details of the PV module used are given below. A. Manufacturer specifications. Obtained from data sheets. These parameters are the main electrical module characteristics, available on any manufacturer data sheets. They are usually given for STC, but the program accepts measurements performed under other conditions to establish the model from on-site measurements in outdoor conditions. These parameters therefore include GREF and TRAFE, the reference irradiation and module temperature conditions during reference measurements, usually standard test condition STC, ISC and VOC, module short circuit current, and open circuit voltage at these given conditions, IMP and VMPP, any operating point in the region of the maximum power point. At these given conditions, μISC, temperature coefficient for ISC. This has only weak influence on the module behavior. When not known, it can be taken as about 0.05%/°C. These are the two main parameters of the one diode model. PVsyst always proposes default values which may be recovered by clicking the default checkboxes. R shunt. It is the inverse of the slope dV/d of the I/V curve around the ISC value. The default value proposed by PVsyst corresponds to a given fraction of the slope, ISC/VMPP. With modern crystalline modules the R shunt is high, i.e. the curve is very flat, and the associated loss is therefore low, so that an accurate determination is not crucial. R series is the internal series resistance of the one-diode model. It is one of the parameters of the model. At STC, not directly measurable using the I/V curve. Its determination is crucial, and has consequences on the low-light performances. Customized IMA incidence angle, the incidence effect. The designated term is IM, for incidence angle modifier, corresponds to the decrease of the irradiance really reaching the PV cell's surface, with respect to irradiance under normal incidence. This decrease is mainly due to reflex ions on the glass cover, which increases with the incidence angle. E. Secondary parameters. μISC, often named alpha, is specified on the main page of the parameters, and used as such in the model. For crystalline modules, its value lies usually between 0.04 and 0.08%/°C. Specified μVSC 127 mV/°C. Absorption coefficient for temperature. Absorptivity coefficient, alpha, 0.9. His is the irradiance global absorption coefficient involved in the thermal balance for determination of the array temperature. Reverse characteristics. Single cell reverse characteristics. Quadratic factor BREV, 3.2 μ/V2. NB. This reverse parameter is only used in the framework of the array behavior special tools, partial shading on modules. Its value is not essential and can be taken as the proposed default. Number of bypass diodes, 3/module. Diode direct voltage, -0.7 V. Diode maximum current, 0 A. F. PV module model, graphs. In the PV module definition dialog, the page graphs shows the general behavior of the model. You can display the following sets of curves. Current vs voltage, often named I/V curves. Power vs voltage, often names P/V curves. Efficiencies as a function of the irradiance. Efficiencies as a function of the temperature. These plots show sets of parametric curves, i.e. for different irradiances, temperatures, series. Resistance or shunt resistance. A. Sizing principle. In PVsyst, the inverter sizing is based on an acceptable overload loss during operation, and therefore involves estimations or simulations in the real conditions of the system, meteor orientation, losses. Taking the following into account. Overload behavior. With all modern inverters, when the PMPP of the array overcomes its PNOM DC limit, the inverter will stay at its safe nominal power by displacing the operating point in the I/V curve of the PV array, towards higher voltages. Therefore it will not undertake any overpower, simply the potential power of the array is not produced. There is no power to dissipate, no overheating and therefore no supplementary aging. Loss evaluation. In this mode the only energy loss is the difference between the PMPP potential power and the PNOM DC limit effectively drawn. We can see on the power distribution diagrams, that even when the inverter's power is a little bit under the maximum powers attained by the array in real operation, this results in very little power losses, violet steps with respect to the green ones, quasi-invisibles. The simulation and the analysis of the overload loss is therefore a very good mean for assessing the size of an inverter. D. Details of losses. While generation of electricity by the solar panel, there are numerous factors which can contribute to loss of energy or the generation of current. There are various factors which may include to loss of generations of electricity. Some of these factors are environmental factors, technical factors, aging etc. 1. Thermal parameter. The parameters of the thermal behavior of the field are defined in the array losses. The thermal behavior of the field, which strongly influences the electrical performances, is determined by an energy balance between ambient temperature and cells heating up due to incident irradiance. Thermal loss factor, U equals UC plus UV asterisk wind velocity. Constant factor loss UC, 20W/m2k. Wind loss factor UV, 0.0W/m2k. 2. Ohmic losses. Definition: the ohmic resistance of the wiring circuit induces losses. E loss equals RWI superscript 2, between the power available from the modules and the power at the terminals of the subarray. The relevant parameter for the simulation is the RW value, which is an equivalent resistance as seen from the input of the global subarray, i.e. the set of MPPT inputs defined in this subarray. You should define one RW value for each subarray in your system. Go ball wiring resistance, 7.23 m. Loss fraction at STC, 1.5%. 3. Module quality loss. Module quality. Deviation of the average effective module efficiency with respect to manufacturer specifications, negative value. Indicates overperformance. Module efficiency loss, minus 0.8%. Module mismatch losses. The mismatch loss is mainly due to the fact that in a string of modules, or cells, the lowest current drives the current of the whole string. Power loss at MPP, 1%. Loss when running at a fixed voltage 2.5%. Lid light-induced degradation. Lid, light-induced degradation, is a loss of performances arising in the very first hours of exposition to the sun, with crystalline modules. It may namely affect the real Performance with respect to the final factory flash tests data delivered by some PV module providers. Lid loss factor, 0.0%. String voltage mismatch. The new tool string mismatch, in detailed losses, provides a pedagogic description of the principles of different mismatch modes. His shows namely that the current mismatch, within a string, is very important, because the current in the whole string is governed by the current in the weakest string, while the voltage mismatch between strings has much lower effects. Power loss at MPP, 0.1%. 4. Soiling loss. Accumulation of dirt and its effect on the system performance is an uncertainty which strongly depends on the environment of the system, raining conditions, etc. Taking into consideration of the dust in the desert region, and we are taking an approximate value of 3%. Horizon. Horizon profile may be defined manually by a set of azimuth/height points in degrees. These may be from on-site measurements, using land surveyors' instruments like compass. They can also be imported from several sources. Solmetric Sun Eye instrument. This is a computerized instrument using a fisheye type camera for the recording of the environmental masks. It provides an horizon height for each degree of azimuth, i.e. 360 points. Carnival is a free open source software. It is based on a geo-referred grid for calculating the horizon line at any place between longitudes 6 degrees west to 10 degrees east, and latitudes 41 degrees to 52 degrees north, therefore largely covering France, east of Spain, etc. It uses satellite data from the Spatial U.S. Program SRTM, Shuttle Radar Topography Mission, giving a grid of altitudes with a 3 resolution, about 92 x 65 m. The horizon of far shadings part is the simplest way for defining shadings in PVsyst. But this is only suited for treating shadings of objects sufficiently far, as we can consider they act on the PV field in a global way. At a given instant, the sun is or is not visible on the field. Typically the distance of these shading objects should be higher than, say, 10 times the PV field size. Defining a horizon profile is a very simple operation with the PVsyst graphical tool. The horizon is a broken line superimposed on the sun path diagram, which can hold any number of height/azimuth points. Horizon measurements, list of height and azimuth of some significant points, can be obtained on-site with a compass and theodolite, clinometer, a detailed map, panoramic or fisheye photographies, etc. Saving horizon profile. A horizon profile can be saved for reusing it in another project or Mateo calculation. It is stored in the /shadings/ subdirectory with an extension .hor. NB, a file with PVsyst format is not an ASCII file and cannot be exported to other software. Conclusion. As per the results that we have derived with the help of PVsyst, constructing a 500 kW power plant in Assessor is deemed feasible. The average cost of such a power plant will be around the range of Rs 2 crore. Constructing a coal-based power plant of the same power will cost much more and will be detrimental in the long run. Solar power generation is yet to be perfected, but based on the history of the accomplishments of mankind, it's only a matter of time and patience. The sooner we shift towards renewable sources of energy, lesser the chances of us causing irreparable damage to the environment. Summary. The paper explains in detail about a 500 kW solar power plant in Assessor, Rajasthan. It explains in detail about the PV module used, the inverter and the losses that may occur during the running of the solar power plant. There are 16 modules in series and 125 strings in this power plant spread across an area of 3,254 square meters. The module and the inverter is properly studied and researched and explained with proper graph. The different types of probable factors of loss are studied and explained in this paper. The PVsyst software uses data from Meteonorm and other sites for the various weather conditions which are explicitly described in the paper. Since the site is made on a desert, there is no possibility of shadow, therefore there is no near shading given to the software. The horizon and the sun path in that region are also calculated and the data is given to the software. Then the software has a feature of running stimulation based of the data entered. The result of the stimulation gives the various data month in a year and also hourly in a day. The report given by the software is given in the paper and also it is explained. Scope of the project. The project report is prepared considering limited time, resources, and maintaining strict social distancing requirements. Due to increase in the price of fossil fuel, carbon emission, draining of foreign exchange and depletion of coal resources, Government of India, GOI, has taken decisive steps towards increasing alternative energy sources. A decision was taken by GOI to bring down crude oil import by 10%. Amongst others, special impetus was given for development of solar energy across India. 7. There has been a steady growth of installed capacity of solar PV as depicted in the graph. With cases schemes like Atmanirbhar Bharat and solar power plant in Ruadi is a huge scope of this project. This is going to create jobs and provide energy to household and also taking care of the environment.